Refractive index. Before start the refractive index, let's see what happens when light enters in any liquid. So this is a drop of water molecule. When beam of light is incident on a water molecule, it may refracted, it may reflected, or it may be diffracted. Or sometime when incident light pass liquid with same angle of incidence, it's called as a transmission. See this example. In this example, this is a water bottle which contains water, or half part of bottle is filled with water, and when we enters the light from lower direction to the surface of water, at that time this beam of light is reflected in the same medium. When we pass the beam of light in the dense of medium, at that time this light is get reflected like this. In this example, bottle filled with water, or half bottle filled with water, and that bottle have a small hole, and beam of light is passed from dense of the medium, or dense of the liquid, or dense of the water, and this water comes out from this hole. The beam of light is also comes with the flow of water, and all these examples are refractions. So this is a familiar example of refraction. These are the sticks. This is a glass of water which is a half filled with water, and these are the sticks. In air, sticks present in air are looking like this, but same sticks when enters in the water medium, sticks become wider, because water has tendency to change the path of rays which comes from our eyes. Due to that change in direction, we feel these sticks are wider than the sticks present in the air. Rainbow is also a good example of refraction. When sunlight bombards on the surface of water droplets, and that sunlight pass from water droplets and get refracted with different directions, with change in different angle of incidence, and due to that change rainbow can observe. We are seeing two different natures of that test tube. In air, the test tube is like this, and in this liquid or in a beaker, change in the path or change the position of that test tube, due to this liquid have a tendency to change the path of radiation which comes from our eyes. But when as we fill that test tube with the same liquid, at that time this liquid is filled in the test tube, and their test tube path of our rays which comes from our eyes does not change, due to same refractive index of both liquids out in beaker as well as in test tube. We does not visualize that test tube in beaker after filling that liquid. This is also example of refractive index. We can observe that the fish is here and actual position of fish is here, but from air we feel this fish is present at this position, because the water is able to change the rays which comes from our eyes. Prism is also good example of refraction. Now see how rainbow forms. This is the sunlight, and that sunlight enters the droplets of water. That sunlight is refracted in different directions, and another surface of water, that refracted radiations is again reflected, and we can observe that rainbow. Refractive index. See, this is a air medium, and this is a dense medium which fills with liquid, or this is liquid medium, and this is air medium, and the incident light is comes from this direction, and angle of incidence is I, and this is a normal. So angle of this liquid have a tendency to change the path of this incident light with different directions towards the normal. So this, suppose I is the angle of incidence and R is the angle of refraction, then according to Snell's law is the relationship between the refractive index of water and refractive index of air. So according to Snell's law, refractive index is n is equal to sin I upon sin R, that is sine of angle of incidence to the sine of angle of refraction, and that ratio is called as a refractive index. So refractive index is also called as a Index of refraction, it is measure of bending of ray of light when passing from one medium to another medium. Refractive index is also equal to velocity of light c of a given wavelength in empty space divided by its velocity v in the substance. Here I mention some examples of refractive index. Air have a refractive index 1.0003, means a ratio of angle of incidence to the angle of refraction is 1.003. Therefore, if air have a refractive index 1.0003, while water have refractive index 1.333 and crown glass have a refractive index 1.517, while that of dense faint glass is 1.655, and in case of diamond refractive index is 2.417. Refractive index of X-rays is slightly less than 1, which means that the X-rays entering a piece of glass from air will be bent away from the normal, unlike the ray of light which will be bent towards the normal. This refractive index of X-rays is less than 1. In these examples, change in the angle of incidence radiation is opposite towards the normal, and therefore refractive index of X-rays is like 1.